That's good. All right, let's get started. Good
Sounds good.
afternoon, everybody. It's time for another exciting afternoon of organic chemistry with your host, me, Dr. White. And before I start anything, an important message. Vote. I voted Thursday. Please vote. Brave men and women have died, so you can vote. The other thing, which is sort of sad, was on Saturday was Halloween, and because Dr. White doesn't want to get the virus, in my town, they suggested sign put on your door, uh, no trick or treating, please. And I put it up because, yes, I always give nice candy out, but giving candy to kids is not worth dying over, which I would probably if I got the virus. And the other sad thing is the first class after Halloween, for all my students, I always give candy. So here's your candy. By the way, I go by the golden rule of giving Halloween candy. Don't give on to others what you don't want for yourself. And this is one of my favorites that I give out. Or I also give out the Hershey bar not sour, cookies and cream. That's dangerous stuff. But these are dangerous, and sometimes M&Ms too. I like, in the little bags. I like M&Ms. But these are my favorite. By the way, chocolate, that's organic chemistry too. All right, quick announcement. A week from this Wednesday will be test 3. This Wednesday, I'll go over the esters problem set, carboxylic acid and ester problem set. Next Monday, I'll go through, because I'm going to finish it this week, the amines and amides problem set. So next week from today, I'll do my back from popular demand, by popular demand, my review for next test, which will be test number 3. And by the way, my back is getting just a little better every day. And maybe later in the week, I'll be able to sleep in my bed again. So with that, let's get going. Now, last Wednesday, we went through hydrolysis of nitrile, how to make a primary amine. Let's do one more. I'll let you try it. And remember, here you take a nitrile, react it with hydrogen catalyst. The one thing I didn't do here was put excess. If I were talking to colleagues, I wouldn't. For you guys, I do. And why don't you try this one, everybody? And that would be, what would be the product or products for the following reaction? And when you're done, give me a thumbs up or smile, all of you. I think I spoiled everybody with my videos. All right, I think looks like everybody's done. So let's do this. How do you do it? You look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention. Here we go, nitrogen, carbon, nitrogen, triple bond. It's a nitrile. Reacting it with excess hydrogen and a catalyst. Remember, the catalyst can be nickel, platinum, or palladium. And what happens is you break the 2 pi bonds. Remember, you have 2 pi bonds. It's like a carbon-carbon triple bond, 1 sigma. You don't break the sigma, you break the pi. Each atom of the triple bond gets not 1, but 2 hydrogens. And if I look at here, what's our T-butyl group? even though in the nomenclature it wouldn't be called that. And then here's my carbon double bond to nitrogen, triple bond, I'm sorry, and my nitrogen, and each one gets 2 hydrogens. And don't forget, there's 4 bonds to carbon, so I can put in the rest of the hydrogens. And here, these two, you could have put CH2 and H2 if you wanted to. And that's how you do it. Any questions? Nope. Let's move on. Now, back when you took general chemistry, you learned about acids and bases. A base is a proton acceptor. And that's the definition of a Bronsted-Lowry base. Acid is a proton donor. We're talking about H+. So ammonia is a very strong base, takes a proton from water, and you form ammonium hydroxide. Oh, by the way, if you ever go to the supermarket and buy ammonia solution, and you can buy it at any, it's really not ammonia, it's really mostly ammonium hydroxide. There's a slight equilibrium back this way, and that's why you can smell the NH3 or that strong smell, but most of it is this. Well, let's look at amines. Turns out amines, whether primary, secondary, or tertiary, and I can rewrite this like this. Where R prime and R double prime can be carbons or hydrogens. And let's make it any base or acid, I mean. Hold on. And let's just keep it to halogenated acids. It could be others too, like sulfuric, where X equals chlorine, bromine, or iodine. And this is a straight acid base. This gives up its acid. And you form an amine salt. All molecules have a net zero charge. Since this has a positive charge on nitrogen, you need an anion. And for this class, we'll stick to halogens. So let's take a look at this reaction. And the question is, what's the reaction product or organic reaction product or products of the following? Look for what's different here. Here we have an amine. In this case, R prime and R double prime are hydrogen, but they can be carbons too. One or both, plus HX. X can be chlorine, bromine, or iodine. And what happens? You have a proton transfer because it's an acid-base reaction. What's attached to nitrogen stays attached. And you add one more hydrogen, actually H+, and so it has a plus charge. And the anion here formed from that is there. So in this case, R is 2 carbons, R prime and R double prime are 2 hydrogens. Notice I'm going to add, here we have, you don't see any, we add one more, So it's time for high-level math. If I have 2 and add 1 more H, what do I have? 3. So one way of writing this, the R group is on nitrogen. This increases to 3 plus charge. What's our halogen? Chlorine becomes chloride. Now you don't have to put charges down, but Dr. White likes to, thinks they're cool. I'm a cool dude, or trying to be. All right, your turn. What would be the organic product or product for the following? Quick reminder, if you have any classes tomorrow at ECC, online or off, they're not being held because tomorrow is a state holiday and all classes at ECC or all ECC is totally closed, including online. Luckily, we're today. All right, let's take a look at this. What's different? Ooh, nitrogen. And here we have a primary mean where R prime, R double prime are both hydrogen. They can be, and in this case, they are. I'll call this R. When you react it with HX, an acid, X can be chlorine. In this case, it's bromine or iodine. What you get is an acid-base reaction, and you get a salt. These are called amine salts. And you don't have to show charges, but it's important to have the halogen anion there just as a halogen. What's our isopropyl nitrogen? We have 2 hydrogens. I'm going to add 1 more. That's 3. And what's my anion? Bromine. Oh, let's do 1 more. These are fun. Let's do a synthesis. What would I react with hydrogen iodide to make this compound? And don't forget during the break to pick up your candy from Dr. White. That's sad because when I have a class like today after Halloween, I bring enough candy so everybody in the class gets at least 2 candy bars. All right, looks like everybody's done. So let's go and do this. What's different here? Ooh, nitrogen, and it's got 4 groups on them. 1, 2, 3, 4, and 1 is hydrogen. I didn't mention it, but if you look up here, an amine salt has 4 groups on them, and at least one of those groups or atoms has to be a hydrogen. There can be more, but at least one will. So we have an amine salt. And don't forget, our prime and our double prime can be hydrogen. And How do I make it? React either primary, secondary, or tertiary amine plus an acid. Remember, X equals chlorine, bromine, or iodine. So if I look at this, what's our double prime, our prime, and our double prime? They're all methyls. Remember, this bracket tells me there are 3 methyls on the nitrogen. And therefore, what do we start with? Our prime, our prime and our double prime, our methyl. I can draw it this way, or if you want, you could also draw it this way. Since Dr. White knows and loves amines, either way would be correct. And that's how you do amine salts. And an important thing, and I'll teach you later about like dissolves like, things that are polar are soluble and polar things. Well, your blood and stuff in your stomach are water mainly. And many of the drugs that the key chemical in the drugs are amine salts. Why? Because this makes it polar and helps make it more water soluble, which means it's better in your blood to be moved around your body to where it needs to go. Not all, but a lot of the medications. And if you see a long name and then either, this is not IUPAC, but something like hydrogen chloride, or a long name and .HCl, that's what they did. They had amine in the compound, reacted with HCl, and that makes it more water soluble. Next time you happen to be in your bathroom where many of you keep your over-the-counter stuff, go take a look. You'll see on the label, maybe the active ingredient is something like that. Now, one of the things I didn't do until now is nomenclature of amine salts. I don't even have a slide for that. So take notes or watch the video again. And here, how do you do that? Well, it's real simple. And it's the same as quaternary ammonium salts. How do we do that? Hang in there. I'm having a bad printing day or writing day. Name each R group on the nitrogen as an alkyl group in front. And this is the common names, just like I did with amines. I'm not going to teach the IUPAC. And then next step, add the words ammonium halide. And let me just remind you, Cl- is chloride, Br- is bromide, and I minus is iodide. I have never worked with fluoride quads. I know they exist, or amine salts, but you're never going to if I've never done it, so I'm not going to do it. So let's take a look at one. And the question is, how do you name this? Give the common name for the following. And on test 3, I'll have nomenclature, and I'm doing something a little differently. I'll have give the IUPAC or common name for the following, and based on the name, common or IUPAC, draw the structure. If we look here, we have an amine salt, and there's one R group, that's ethyl, and add ammonium, and then it would be chloride. I'll do one more before I let you try one. And if we look here, what do you see? Ooh, nitrogen with a hydrogen and a plus charge and an anion, and it's amine salt. Now, one of the things students always ask me is, Dr. White, how can you tell the difference between an amine salt and a quaternary ammonium salt? Quaternary ammonium salts always have 4 R groups. An amine salt on nitrogen has at least 1 hydrogen, never 4 R groups. And that's how you can have more than one. So how do we name this? Well, it's dimethyl then this is N-propyl ammonium chloride. And that's how you do it. Name the alkyl groups, add the words ammonium chloride. And I'll give you one to try. Am I nice or am I nice? Don't answer that. And while you're working on it, everybody, let me remind you, tonight, if you have any questions from 6 to 7:15, I will have my office hours. And if you need any help, come on by. All right, I'll wait until everybody's done. Oh, I think everybody just finished. If we look over here, what do we have? Ooh, 3 R groups on nitrogen. Look for what's different. It's got a hydrogen with a plus charge and a anion. It's an amine salt. And how do we say three? I don't even, my brain is short circuited. Hi, Alondra. Hold on. Quick thing. Don't forget to vote. I did. And unfortunately, you came late, but I'll still, here are your candy bars. I always give out candy at Halloween to my classes. But anyways, what do we have? An amine salt, and this is trimethyl, or ethyl, I'm sorry, ammonium, and the anion is iodide. Just a quick thing for in case you missed it. Don't forget, I'll be posting the video of this, so if you missed anything, You can always go back and watch it. But instant replay, how do you name an amine salt? Same as quaternary ammonium salts. Name each R group on the nitrogen as the alkyl group it is. Put that in front. Then add the words, excuse me, I'm getting all choked up over this, ammonium halide. And remember, if it's Cl, the halide is chloride, Br minus, it's bromide, I minus, it's iodide. Now, there are two types of nomenclature question on test number 3. And the other one is draw the structure for the following. And why don't you draw the structure of N-butyl ammonium bromide? Oh, by the way, Alejandra, I was just thinking back when I was in college, I had a ponytail too. Don't even think of that. Oh, you're thinking of it. My hair used to be down to about here. My beard was out to here. My beard was so, someone bet me, and I think I was able to hide 4 or 5 pencils in it. It was that thick. Oh, the good old days. And the good days now too. All right, let's do this. How do you do this? You start from this side, move that way. Ammonium halide, that tells you it's either an amine salt or a quaternary ammonium salt. And how do you tell which is which? Well, count the alkyl groups. Amine salts is going to have, remember, R prime and R double prime can be hydrogen for an amine salt. For a quaternary ammonium salt, nope, R prime and R double prime and R triple prime have to be all alkyl groups. And Dr. White's been real good chemist. He hasn't used slang and shown a bad habit for my students when we're talking about quaternary ammonium salts. And again, all R groups have carbon atoms. In other words, they're alkyl groups. So in this case, there's only one alkyl group. It's an ammonium salt. So I have N-butyl, 4 carbons. Then nitrogen. Now, for quaternary ammonium salts, there's always 4 groups on nitrogen, and therefore, I have 1 alkyl group. I need 3 hydrogens. You don't have to show the charge. What's the anion? Bromide. And I know there are 4 bonds to carbon. And I'm done. And there, your turn, dimethyl ammonium chloride. Well, it looks like everybody's done, so I better get to work. What do we have? We start from the right, move left. Ammonium chloride, that can be a quaternary ammonium salt or an amine salt, but there are only two alkyl groups, so I know it's an amine salt. What's diethyl? Two ethyl groups on a nitrogen. You can write it this way. Notice for an amine salt, you need 4 total bonds to nitrogen, covalent bonds. So I'll have 2 hydrogens. Chloride is Cl like this. You could have also written it this way. Again, you don't have to show the charges. Dr. White will. And that's how you do it. Any questions on that? It turns out Mother Nature uses amine salts in many things in your body that I'll talk more about later in the semester. We get into other things like amino acids. Ooh, you know what time it is? It's new functional group time. It's time for a new functional group. And what's that new functional group? That new functional group is the amide. And the amide, which I have drawn here, well, let's draw it over here. It's a carbonyl, carbon double bond oxygen with carbons. Is carbon of the carbonyl is bonded to nitrogen. And on the nitrogen, you have R prime and R double prime. And turns out R prime and R double prime can be hydrogen or it can be alkyl or arrow-benzene ring. Now, this functional group area, I'll have to admit, I'm going to tell you probably one of the dumbest things I ever did in my life. Well, luckily, because I knew organic chemistry, I saved myself real quickly. But what I did was stupid, big time. And I'll also teach you things you never thought you learned in organic chemistry. Now, I'm not going to go through nomenclature of amides, both common or IUPAC, both exist, because you're not going to deal with them per se in your daily life unless you work in the chemical industry like I am. Now, switches off for this type of this slide. This real quick. This is called a primary amide. This will never be on a test. This will be called a secondary amide. And this is a tertiary amide. And like I said, switch is totally off. And this is where in secondary, R prime is not hydrogen, and tertiary R prime and R double prime for tertiary amide are not hydrogen. Switches off. I don't know why somebody decided you can have cyclic amides, just like you can have cyclic esters, and they call them lactams, but they're still amides. Why they did that, I don't know. Switches off. All right, switches on. Now, it turns out, even though amides are like this molecule where this is my R group, is still considered an amide. It does a lot of the same chemistry as amides. And important thing, this is called urea. It's a white solid at room temperature. I've worked with it, lots of it at one company. And it's the way your body gets rid of nitrogen waste. It's the major organic compound in urine. I wonder which came first, the name urea or urine. One day I'll look that up, but not today. And it's a very important industrial chemical because it's used to make various polymers such as urea formaldehyde. And I worked for a company and I actually designed polymers using this. One of my more, how should I say, unpleasant memories with urea, if you work in the chemical industry, they have something called a super sack. They're these big, thick, it's not really cloth, it's a plastic like, or almost like a nylon or plastic sacks that they sell powdered chemical in. And they're 2,000 pounds. And I was running, when I worked for Borden Chemical, when I would have a new product of mine being run in a plant the first or second or third time, especially the first time, I would be there. I'd have other chemists there. A chemical plant runs around the clock. We do 12-hour shifts. I usually took from 6 a.m. to 6 p.m. I'd have one chemist who worked at that plant, at the research at that plant, through the midnight. And he liked it because he could spend the day with his kids. He had 6 of them. And so he liked doing when I came in, would volunteer to do the night shift with me. Well, anyways, one time we're about to start, we needed, I don't know, 4,000 pounds of urea. And we opened one in a super sack. I was out there watching them, and the thing was caked. It was like a solid brick where it should be a powder. And if it was not a powder, we're not going to get that into the reactor. So one of my more, how should I say, interesting and not the most pleasant memories was me and 8 other guys with sledgehammers breaking up 2,000 pounds of urea. It took us about an hour or so. That was a good workout. But you do what you got to do. And one of the things that did help was that cemented my image being someone these guys really like, because as a PhD, I could have just gone in the control room and said, all right, get it done. No, I grabbed the sledgehammer and helped. And plus the other thing, did I tell you about Krispy Kreme donuts? We got time? Yeah, I got a couple of minutes. It always pays to make sure the people in the plant like you. Most PhDs don't know that lesson, come in, I'm tough, I'm super brilliant PhD, kiss my ring. Yeah, wrong. I went in there in the first day when someone called me Dr. White, and I said, no, here's my first name. You're no better than me. I'm no better than you. You know how to run equipment. I know how to do some chemistry you don't know. You know how to do a lot. I don't know. Let's work together. Plus, at that plant, before I went down there, I was told by the research director that the people there and the plant manager hated research people big time, which was unusual, but sometimes they happen, but not just across the board. And he warned me, don't be upset if they're really mean to you. I said, okay. I said, is there a donut place near that? And this is in Kentucky. They said, yeah, there's a Krispy Kreme not far from where your hotel is. Said, and I had a company credit card, American Express, and I think that one had a $25,000 a month limit. I travel a lot of times. And I said, do you mind every day if I buy donuts for everybody in the plant? And the research director said, why? I said, so they'll like me and they'll be nice to me. He said, never thought of doing something like that. So I went down there, and first day I come in, here I am with 10 boxes, each box a dozen for everybody to have more than one donut. And then I bought 10 of my favorite, which is the chocolate with the white kind of cream is inside. It's not really a donut. It's like a Bismarck French cream or something that's really sweet and nasty and too many calories. I bought one of those and the rest of regular glaze. Those went like that and the rest slowly went. The next day I bought 9 boxes of the chocolate covered with the filling and 1 glaze, and the glaze were the last ones to go. And after that, every time I went in there every day, and if I was there for 3 or 4 days every morning, the other thing I did was their shift started at that plant had 2 shifts, 6 a.m. to 6 p.m., 6 p.m. to 6 a.m. The new shift always got to the control room 15 minutes before they started so they could talk to the people who are leaving, find out what's going on. Was a PhD at my level, I didn't have to show up when they did, but I did. I was always there at about 5:30, stayed till 6:15 for the changeover. Also, I wasn't that far away, a couple miles away in a hotel. If there was something they couldn't handle, or the chemist I had there, I got a call in the middle of the night, and I would get dressed and get down to her and handle it on the phone. But I brought those donuts. The other thing is I treated them with respect. Just because I'm dealing with someone with a high school diploma and that's it, doesn't make me any better or that person any worse. And guess what? About a month later, the research director called me into his office. I think it was more than a month, but not that much more. I said, "What's wrong?" He said, "I just got off the phone with the plant manager of their Kentucky plant, which was the biggest plant the company had. And he said, they really like you." He said, "What the hell are you doing?" I said, "Well, I'm being nice to them and I'm feeding them donuts." He said, "It's amazing. You're the only person they've ever been nice to." And I found out other PhD chemists from our site, also in the Kentucky lab, treated them like they were garbage. Well, guess what? You treat someone like garbage, they're not going to be nice to you. It's called common sense. And one of the greatest, how should I say, mentors I ever had since Shapiro used to always beat my head. Common sense is not common. With that, let's take a break. Be back in 5. We'll get to talk about Amides. I won't charge you extra for that life lesson. I'll see you in 5. At 150. 155. Sorry, did my math wrong. Let's get started. Sorry about being late. I got my mail and I didn't put on rubber gloves, so I had to wash my hands because you never know what's floating on the mail. Even though it should be safe when it comes to my life, I don't take chances. All right, we're talking about amides. Now, like I said, urea is an amide. Now, again, an amide is anything you have R group with a carbonyl, then nitrogen, then R prime, and R double prime. Note R prime and R double prime can be hydrogen, or they can be alkyl, meaning carbons, or a combination of alkyl and hydrogen. Now, it's time for me to talk about the dumbest thing I ever did in my life, one of them. I've done more than one, unfortunately, but show me somebody who has, and I'll show you someone who's lying. But have you ever heard about peppers? And you know how some peppers are really hot and some are mild, got a little heat. Well, what makes them that way? It's this molecule. The common name is called capsaicin. How it got that name, I don't know. But if you look here, we have each bend of the line is a carbon, end of the line is carbon. Notice right here, you have a carbonyl, nitrogen with a hydrogen and an R group. I'll call it R prime, and carbons attached to the carbonyl, and this is an amide. And the more capsaicin present in a pepper, the hotter it is. If you look at red peppers or green peppers, there's almost none in there. If you go to, I don't know, say jalapeno peppers, there's a nice amount of capsaicin. Then if you go to habanero or ghost peppers, there's a lot. Now, I don't know if I mentioned it, but there's a great place, and they've got a couple of stores in the area. One's in Evanston. I don't go there anymore. I got lazy. I just have them ship it out, called the Spice House. Let's see if can you all see the Spice House website on the screen? Thank you. Now, number of years ago, they just started selling this ground habanero chilies. That doesn't look that dangerous. And they sell it both in a bag and a shaker bottle, which or a half cup. They don't even sell it in the bottle anymore, but they used to. And so I bought a bottle. Yes, they do. And it doesn't look too dangerous. So Dr. White did something stupid. I got home, looked at it. Doesn't smell interesting. I said, I wonder how hot it is. I went like this, touched the top of the bottle where there was a little powder, went like this, and immediately I realized I have just done something wrong. Because my tongue, my inner lips, part of my mouth were in instant pain. Not hot, pain. I mean pain. And I'm thinking, I better get myself to the hospital, or then all of a sudden organic chemist kicks in. I'll teach you later on, there's a principle called like dissolve like. Things that are polar are soluble in polar things. Things that are non-polar are soluble in non-polar things. You try to mix the two together, they're not soluble. Which is why if your mouth's on fire like that and in serious pain, water will do nothing because it's polar, capsaicin is non-polar. Well, I happen to know vegetable oil and fats and oils are non-polar. Well, I happened to be standing right next to my refrigerator when I did this, and underneath right by me was where I have my silverware. I got a tablespoon out, opened my refrigerator, and I know, and I'll teach you later on again, I grabbed a jar of mayonnaise. Mayonnaise is 50% water and about 50% oil. It's an emulsion. I'll teach you more about that later on. But there's a lot of vegetable oil. I took a teaspoon, a tablespoon like that, put it in my mouth, switched it around, went to the sink, spit it out, did it 2 more times, pain gone, totally. And that's because like dissolves life. Now, I could have done shots of vegetable oil, but the mayonnaise was quicker to get my hands on, and that would have worked too. Now, how many of you have ever been at a place where they sell hot, very hot buffalo wings? What do they always serve with it? The little cup with the celery, which won't do anything good if your mouth's on fire, but they have like a ranch dressing or similar almost. And what does that have? A lot of fat in there. And that will help get it the heat off your lips and in your mouth. Now, how many of you ever seen someone eat a chili pepper or ghost pepper or Thai chili pepper at a Chinese place? And what do they bring them? Well, they bring them a glass of milk. And whole milk has a lot of fat in it. And that's how it gets it out. Now, if you also wanted to, you could always just take some butter or put butter on crackers and get it in your mouth. But now you know the secret one. Don't tell anybody about the dumb thing I did. I learned my lesson that day the hard way. Oh, the pain. I mean, it wasn't hot. It was sheer pain. Now, I use that stuff. Now, when I make chili and I have this, I'll take it. If I have a big pot of chili, like I'll just go ding, ding, ding. That's enough to give it some heat, good heat, along with other things. Now, by the way, the Spice House is a really good place to get your spices. When I used to go to Evanston's store more than once, the owners would point out when the customers there were some of the top chefs in Chicago. That's where they got their spices. Why did they point it out? One time I was there and I saw they were having trouble with a balance. Being a chemist who knows balances, I said, can I help you out? And I helped them fix it. And they were forever grateful. And so whenever I went in there, the owners would say, hello, how you doing? All that, because I remembered. They didn't give me any discount, but I didn't ask for any. But it's a great place. They have the best cumin, the best chili powder. They actually have 3 different types, mild, medium hot, real hot. I get the medium hot because the real hot, if you put enough in to get the chili, it gets the chili powder taste. It gets whatever you're cooking too hot. But I also put in the habanero, which has an amazing, besides heat, floral taste to it. Interesting taste. All right, let's get back to Amides. Now, I better tell you one more Amide story. Today's real good. I worked for a company that made Amides, and one of the products they made was called the Rusamide, where R is a very long carbon chain with the carbonyl carbon, about 20 carbons. Then on the nitrogen, you have 2 hydrogens. Have you ever gone to a supermarket in the vegetable produce area? You grab one of the bags off the roll to go put your produce in that you can pick. Oh, by the way, I live near Valley Produce and Meat Market, and they are the best. They're much better than Caputo's and Tony's. Tony's, much better. They only got about 4 or 5 stores in the whole North Chicagoland area, but if you're near one, go to it. It's great. Well, anyways, you pull it off and you try and open. It says open this end. It won't open. Well, it turns out plastic alone, because of van der Waals forces, will stick together. And they put a molecule in there called the slipper agent. It makes it slippery, so it slips apart. And the slipper agent is a Rusamide, that amide. And it comes to the surface of the plastic bag when they make it. It makes it slippery enough that you can open it. Whenever I grab a roll, back from a roll, I can't get it open. I'll throw it out in a proper receptacle. I'll go to a different roll because the company who made that roll were too cheap and didn't put enough slipper agent in there. So now you know. All right, how do you, and let's skip this slide. You'll see why. Let's go to the next slide. How do you make an amide? You take a carboxylic acid, and an amide is a derivative, something made from a carboxylic acid, and react it with this molecule. Now, let me talk about this molecule and why I skipped the slide before. This one, R prime and R double prime, can be hydrogen. And what happens is you lose this hydrogen and OH. I don't show it here, but now I will. You form water, in this case, and you make an amide. That's how you make an amide. When I worked for AXO, we used to make about 1 million pounds or more a week, every week, sometimes a lot more. And that's how you make an amide. And the question would be, what's the organic product or products that are following? And now you look at each molecule and identify the functional groups, what's different. Carboxylic acid, the 2 oxygens give it away. Ooh, nitrogen. Now, let's look at this one. We've got an R group and 2 hydrogens, but they could be R and R prime. Remember, R prime, R double prime can be hydrogen. And therefore, if we take this, we'll make an amide. Now you make water, but I'm only asking for the organic compounds. Now if we look here, what's our methyl? What's our prime? Methyl. What's our double prime? One of these, hydrogen. Therefore, keep your eye on the carbonyl. Carbon, what's attached to it? R, which in this case methyl, is still attached to it. Then on nitrogen, you have a methyl. You could have put it down here too, and a hydrogen, and that's how you do it. Let me do one more. And let me do this one, then I'll let you try to, because you know Dr. White's going to share. And the question is, what's the organic product or products that are following? And if we look over here, we'll see, ooh, what's different? Carbonyl, hydroxyl, we got benzene ring. But will benzene react with this molecule? And the answer is no. So it's really just a carboxylic acid. Ooh, we've got a nitrogen, and it's got a hydrogen and 2 R groups, R prime and R double prime. React them together, and you'll form an amide. And in this case, what's our benzene ring? One of these I'll call R prime, doesn't matter which is which. The other is R double prime. Keep your eye on the carbonyl carbon. Becomes this carbonyl carbon. So I'll draw that. Let me go up here. And I have my carbonyl. What's attached to it? R, benzene ring. Don't forget the double bonds in there. Then I have my nitrogen. One R group, R prime, is methyl, and the other is ethyl. And why don't you try this one? What would be the product or products for a following reaction? Have fun. And when you're done, give me the thumbs up or the high sign. If you've ever seen our gang, it's on YouTube. Check out the high sign with Spanking Alfalfa. If you don't know what I'm talking about, you're missing something really great. Look at Our Gang. It's used to be in the movies, a serial type thing, a program that was from the 1930s. But by the time I was a kid, it was on TV every week. All right, let's do it. I think everybody's done. What's different? Ooh, 2 oxygens here, carbonyl, hydroxy group carbons, carboxylic acid. Carbon, carbon, ooh, nitrogen. And it's got hydrogens and carbon. Notice that nitrogen has at least 1 hydrogen. And here, remember, R prime and R double prime, 1 or both, can be hydrogen. In this case, 1 is. So I'll call this R prime, and one of these hydrogen R double prime. And let me finish up down here. Here you get an amide. Keep your eye on the carbonyl carbon, because that's where the fun is. Now you know I said carbonyl carbons are the best. They're in a lot of important functional groups. So here's my carbonyl carbon. I'll draw that first. What's attached to it are 2 carbons. Remember, there's always 4 bonds to carbon. In amides, the nitrogen always has only 3. And what's R prime and propyl? And a hydrogen. Now, if you switch to hydrogen and propyl, that's fine. And that's what you make. Ooh, let's do another one. Your turn. What would be the organic product or products for the following reaction? Every time I think about capsaicin, I think about, wow, how lucky I was. I knew like dissolve like in organic chemistry. Oh, is that painful? Oh, I should have pointed out that, will this compound react with the benzene ring? The answer is no. All right, looks like everybody's done. Let me check. Is everybody done? Yep, they're done. Now, what do we have that's different? Ooh, two oxygens to the same carbon. Got a carbonyl carbon, hydroxy group carbons here. We have a carboxylic acid. Ooh, nitrogen. With two R groups, there should be a 2 there. I apologize. Bad, Dr. White. I have a secondary amine where R and R prime are carbons, but R and R double prime can be. They're not in this example. And what do you get? Keep your eye on the carbonyl carbon. What's attached to it is still attached to it. Then you get a nitrogen, R prime, and R double prime. And here, what's our R group? This right here, the benzene ring with a methyl group in the meta position, 1, 2, 3. And we have two ethyl groups. I'll call this R prime and R double prime. And if I draw it, I'll draw my benzene ring, my R group. Carbonyl. What's on my nitrogen? My two ethyl groups. Now, there's another way I could draw this. And that would be like this. And this is CH2, CH3. Either way, let's call this A or B, would be correct on the test. So that's how you make an amide. Now, one of the things I've been asking for a while now is that you should be asking, why am I learning this stuff? And the obvious answer is because you want to get into a program or a school that makes you take organic chemistry. But why are we making this, learning this stuff? Well, let's take a look. Let's go out in the real world. And can everybody see the Wikipedia page now? Have you noticed they have something called DEET? DEET is N-N-diethyl meta-2-amide, and its acronym is called DEET. And NN in front of diethyl tells you these are on the nitrogen of an amide. Now, here's the structure. Notice I have two methyl ethyl groups on the nitrogen, 1, 2, 3. Pair on the benzene ring, I have a methyl here. And guess what? That's what you just made. What is DEET? DEET is the active ingredient in any mosquito or repellent. And if you go to your local big box store, if we're coming into summer, like I do every summer if I need it, I buy the DEET spray mosquito repellent, which is essentially DEET and some solvent, but mainly DEET. Now, time to learn something from Dr. White. But you never thought we'd get into mosquito repellent and organic chemistry. Yeah, you didn't. But anyways, many, many years ago when I bought this house that I live in, first time I went out to the lawn, which I have a pretty big back and front lawn at a good pace, usually takes me about an hour to do front and back. It's pretty good size. But anyways, I go out there Saturday morning, about 8:30 in the morning. I start mowing my lawn. All of a sudden, zoom, zoom. I get attacked by every mosquito in the northern suburbs. And I figured, I got to get some mosquito repellent. So what's the closest big box store? Walmart. So I put my lawnmower away, go over there. And I go to the area where they have the mosquito repellents. They have a bottle of Off, the name brand. Then they have their stuff. Now, because Dr. White knows the active ingredient, now you do too, is DEET. I look at the two bottles, they're the same volume. The Off is twice as expensive as the Walmart brand. And then I turn the bottle over and I look at the Off, and this is their deep woods extra strength one, has about, I'm guessing now the number's been a while, let's just say for argument, 2% DEET. I look at the Walmart, their label brand, and it has 4% DEET. So it's got twice as much as the active chemical. It's half the price. Guess what I buy? Not the name brand. And I've been using it ever since, and it works quite well. Because sometimes this summer, if I'm out there at 8 o'clock in the morning, the mosquitoes are quite active and hungry, but they stay off when you use the DEET. And now you know, and you can tell your friends, neighbors, and loved ones that DEET is an amide. No, don't. They don't like hearing organic chemistry, I'll bet. Oh, let's have some more fun with this. And I'm going to let you have fun. On test number 3, there's going to be 3 or 4 syntheses. What two things do you react together to make that molecule? This is the fun part of organic chemistry, at least for Dr. White. And by the way, if you look at the syllabus, Dr. White's on track. We're on schedule, which is a good thing. And looking back, I'm glad I added an extra week before test number 2, because I think you people needed it. But now we're on track. And when you're done, give me a thumbs up, all of you. Oh, hold on, I think we're all done. All right, how do you do this? You look at the product and say what's different, what's not carbon, what's not oxygen, nitrogen, carbonyl, nitrogen to the carbonyl. This is an amide. And here we have R prime and R double prime can be hydrogen. Actually, R can too, but I won't do that in this class to you. And how do you make an amide? A carboxylic acid plus an amine will make an amide. Remember, R prime and R double prime can be hydrogen. And now if we look over here, I'll call this R, I'll call this R prime, I'll call this R double prime. And therefore, if we look here, what's attached to the carbonyl carbon, the methyl group R, will still be there. And then I have my nitrogen, R prime is ethyl. I'll have our double prime hydrogen, plus you add one more hydrogen, And that's one way of writing it. You could have also written it this way. And either one would be correct. Oh, let's do one more. I love doing synthesis. Your turn. What would be the two starting materials I'd have to react to make that molecule? All right, you guys are quick. Oh, it makes me feel so good. I'm very proud of all of you. All right, let's take a look at this. What's different? Ooh, carbonyl and a nitrogen to the carbonyl. I have an amide. And our prime and our double prime can be hydrogen. In this case, they're not. Well, here's a carbonyl. What's my cyclopentane ring? What's our prime and our double prime? My methyl groups. And therefore, if I come over here, oops, Dr. White forgot to do this. How do you make an amide? Carboxylic acid plus an amine. And therefore, what's our cyclopentane ring? Carbonyl hydroxyl group. This is carboxylic acid. What's our prime and our double prime? Methyl groups. And I have one hydrogen. There are two of them, or you could have drawn it this way. Either way would be correct. And that's how you do amides. Now, one thing I neglected to tell you, and I better do that, is you know where you can find amides real quick, not to scare you? Touch your skin. The bond that holds your amino acids together to form your skin are amides. If you look there and say, oh, look, I see a lot of amides. And if you look at what's left here, my hair and yours too, that's amides, polyamides. And I'll teach you more about that when we get into proteins, peptides, and amino acids, because these are all amides. How about that? This is not. I'll teach you what that is later on too. All right, hang on. Let me do something. I don't know why it's being. Hold, hang in there. Once in a while, when Zoom starts playing nasty with Microsoft Word, so I got to close it. All right, let's try again. Let's see if it's not going to. Success. Aren't you glad your instructor's a power user, knows how to go into Task Manager and close things? I am. All right. Now, once you have an amide, what can you do with it? Well, you can react it with acid and water. Now, for this class, and I'll explain why, the only acid we'll deal with is HCl. And if you have an amide, I'll write it this way. My software doesn't like the way I write it normally, so it fights me. Remember, R prime and R double prime can be hydrogen. If you react it with, and I can also put it like this, HCl and water, you'll get back the carboxylic acid you would have used to make that amide, plus the amine salt of the amine you would have used to make that amide, which is what I have down here, this different way, and here's this. Now, it turns out this is a very important reaction. We say that about all reactions, but this one is right here, because we're going to come back and talk about it later in the semester. Why is it important? All right, got a quick question for you. Everybody, pop quiz. No, I don't do quizzes. Anyways, where can you find in the room where you are right now, real quick, hydrochloric acid and water? 1,000, 2, 1,000. Time's up. Put down your pencils in your stomach. Your stomach has HCl. It's always one of the wonders of life that I have, and you have cells in our stomach. I don't know if they're in your small intestine too, that generate, synthesize hydrochloric acid. And if you've been doing what I've been doing today, drinking some water, you also have water in there. And that reaction, acid hydrolysis of an amide, is how your body breaks down proteins, which is quite important, because that's how you get the amino acids for muscles, your skin, what's left of my hair, my beard, all the good things in life. And that's the important thing. Now, let's go back and look at an important feature of this reaction. Quick question, everybody see the whiteboard I'm writing on? Good, thank you. Quick answer. And what you get back when you do acid hydrolysis of an amide is the carboxylic acid you would have used to make that amide, plus the amine salt of the amine you would have used to make that amide. Now, why do you get the amine salt, not the amine? Let's take a look at stepwise. And what I'm writing on underneath, you do not have to write down. I'll never ask it on test. When you add acid and water, you'll get acid hydrolysis. You'll get back the carboxylic acid plus the amine you would have used to make that amide. But if you notice, I'm putting it in brackets, this amine. Why? Because you can't isolate it. In the presence of acid and water, as I talked about earlier today, you take an amine, you'll make the amine salt. And this is probably the fastest type of reaction in all of chemistry. It's called the fusion control. As soon as the two compounds touch, they react immediately, even faster than I can say immediately, in a nanosecond. That's the billionth of a second. So you'll never see the amine, you'll see the amine salt, which means if you put down the amine instead of the amine salt for this answer, I'll mark it wrong. Because in the presence of acid, this will always react to make the amine salt. And why don't we do the following? And the following would be, give the organic product or products for the following on a test. I would do that to help you out. I'll do this one, then you have some fun. What do we have that's different? Ooh, oxygen, nitrogen to the same carbon. Carbonyl, nitrogen, carbons here, carbons here, carbons here. This is an amide. And remember, our prime and our double prime can be hydrogen, but in this case, they're not. HCl, water. We'll get back to carboxylic acid we would have used to make that amide, plus the amine salt. Of the amine we would have used to make that amide. So here's our prime, here's our double prime. Keep your eye on the carbonyl carbon, becomes this carbon. Whoops. Dr. White's big fingers touched a button on my stylus. And therefore, you'll get R is methyl, our prime and our double prime are methyl, or you could have written it just as easily like that. And that's how you do acid hydrolysis of an amide. Like I said, if you had anything for lunch or breakfast that had protein in it, guess what? There's a organic chemical reaction going in your stomach that breaks it down. I'll teach you that later on. All right, your turn. Ready, set, go. First one done and second one done. Guess a Kit Kat? No. You just have to stick your hand through the screen. That was awful. All right, looks like everybody's done, so I'm going to get to work. What do we have that's different here? Oxygen, nitrogen to the same carbon. What do we have? Amide. On the nitrogen, what do we have? Two methyl groups, our prime and our double prime. Remember, our prime and our double prime. Oh, Dr. White was looking at it wrong. You got to see one of my rare mistakes that I caught in this nick of time. If we look here, we have a hydrogen and an isopropyl group. And I'll call one R prime, the other R double prime. Remember, R prime and R double prime can be hydrogen. In this case, one of them is reacted with HCl and water, acid hydrolysis. And what do you get? You get the carboxylic acid you would have used to make that amide, plus the amine salt, not the amine, that you would have used to make that amide. You don't have to put charges there. I do. So let's call this R prime, this R double prime, this R. Therefore, my carboxylic acid will be that. Then I'll move up here. R prime is hydrogen. Add another hydrogen, add another hydrogen, because I'm adding, notice I add two more hydrogens. And then I have an isopropyl. The anion, don't forget the chloride. That's one way of writing it. And if I wanted to, I could flip this around. Another way of writing it. Notice there are three hydrogens on this nitrogen. And that's how you do it. And if I look at the clock, it's time to take a break again. One clock is different from the other. Let's take an extra break because I need to stretch my back muscles. And I'll see you at 2:50. And with that, I'm going to go stretch my back muscles because they're telling me, stretch me. Let's get back to work. I see all the classes back. Hi, class. All right, we were having fun with amides, and let's have a little more fun. And why don't you try this one for your fun and enjoyment on this Monday before the most important election of my lifetime, I'll bet yours too, tomorrow. Make sure to vote, please. Say a prayer for our country if you're religious. Light a candle. Anything else. Just don't sacrifice your firstborn. Do that to Abraham. Dr. White knows his Torah. All right, looks like everybody's done. Let's take a look at this. What's different? What's not carbon? What's not? Ooh, oxygen here, nitrogen, it's the same carbon, carbonyl, nitrogen, carbons here. On the nitrogen, I got stuff. I'll call it R and R prime. Remember, R prime and R double prime, either one or both, can be hydrogen. And in this case, it is. And what happens when you react an amide with HCl and water, acid and water, you have acid hydrolysis, you get back the carboxylic acid you would have used to make that amide, plus not the amine, but since you're an acid, you get the amine salt of the amine you would have used to make that. I got too many lines here. Hold on. Oh no, I'm getting prime poisoning. But that's better. And like I said, R prime and R double prime can be hydrogen. So if we come over here, this is R. I'll call that R prime. I'll call that R double prime. So my carboxylic acid has my R group. Next, my nitrogen has, I did make a mistake here. Day before an election, I always make mistakes. Did you buy that? Anyways, and you'll get the amine salt, and therefore this will be R prime benzene ring, R double prime hydrogen, then you add two more hydrogens, plus charged chloride anion. Now, this amine salt, you could have also written this way. Either one is correct on a test. And that's how you do it. Now let's have fun with synthesis. Dr. White's just done what he didn't want to do. And this is a cyclohexane ring, not a benzene ring. All right, what would you react with HCl water to make these two compounds? By the way, all of you have been great students today, so after class, make sure you pick up and get your candy bars. It does make me sad because it's so interesting to hand out candy bars at the beginning of class and have a classroom with students on a sugar bus. All right, looks like everybody's done. Let's do it. If I look at this, ooh, I've got two compounds. What's different here? Carbonyl with two oxygen hydroxyl. This is a carboxylic acid. Ooh, an amine salt, which I can write like this. And what do you react with acid and water to make that? Hydrochloric acid? And the answer is an amide. Remember, our prime and our double prime, one or both can be hydrogen. And if I look up here, I'll call this my R group. This R prime, and one of the hydrogens are double prime. Because notice this has 1, 2 hydrogens, this has 3, so one of those has to be my R double prime. If I come back over here, my R group is this cyclohexane ring with a methyl attached to carbonyl here, my nitrogen. One of the R groups, R prime, is methyl, the other hydrogen. And that's how you do acid hydrolysis of an amide. Now you can also do base hydrolysis, and I'll use sodium hydroxide. You could use other bases. And let's take a look at this. If I have an amide, remember R prime and R double prime can be hydrogen. I wonder if I'm near the Guinness Book of World Record of saying that one afternoon. Anyways, you react this with sodium hydroxide, and water, what you get back is not the carboxylic acid you would have used to make that amide, but the carboxylate anion of the carboxylic acid you would have used to make that amide, plus the amine of that you would have used to make that amide. Now, what I'm going to show you underneath, you don't have to write down, but you might be interested in why do we get this? Initially, when you do your acid base hydrolysis, you'll get the carboxylic acid used to make that amide, but I'm putting in brackets because you can't isolate it, plus the amine you would have used to make that amide. But you're in the presence of base. Carboxylic acid is an acid. You have an acid base and you form the carboxylate anion. As I mentioned earlier, there's nothing faster in all of nature and chemistry than an acid-base reaction. And therefore, if you make any of this, it will immediately react with this to make this. So if you put down the carboxylic acid here, I'll mark it wrong. Please don't. So let me do the following. I haven't done this in a while, but let me just check. Everybody see my whiteboard? Thumbs up, people. Thank you. All right, question is, what's the organic product or products for the following? Remember, these are the building blocks we use to make things. Mother Nature uses these. And if I look here, ooh, oxygen, nitrogen to carbon. And what do I have? I have an amide. And I'm reacting with base and water. And what do I get? I get the carboxylate anion of the carboxylic acid I would have used to make that amide, plus the amine that I would have used to make that amide. And remember, R prime and R double prime can be hydrogen. If we look here, I'll call that R. Keep your eye on the carbonyl carbon. And one of these I'll call R prime and the other R double prime. And therefore, I'll look at the first thing. I get my carboxylate anion, R is methyl, and I get this. Next, my amine, R double prime is then butyl. 4 carbons, the carbon bonded to the nitrogen here will be bonded nitrogen here. Then my R group, R prime or double prime hydrogen, add 1 more. And that's that. You could have also written it this way. And either way is identical, and that's what you get. And it's your turn. Have fun. All right, looks like everybody, nope, not yet. Everybody's done. I was right the first time. All right, we look here, what's different? Oh, benzene ring, but that's not going to react with sodium hydroxide and water. I have a carbonyl, nitrogen, that carbonyl. I have an amide. Remember, our prime and our double prime can be hydrogen. In this case, they're not. I'll call this R. One of these doesn't matter which you call R prime and the other R double prime. And I'll remember when you react this with base and water, you get back the carboxylate anion of the carboxylic acid you would have used to make that amide, plus the amine you would have used to make that amide. And if we look here, carbonyl, R group is a benzene ring. Get the carboxylate anion, not the carboxylic acid. So I'll mark that wrong. And what else? You'll have this amine. Now you could have put the methyl group on this side, the ethyl on that side. All you're doing is rotating it 180 degrees. Remember, molecules are not stuck on a piece of paper, and that's how you do it. And the next one is, what do you react with sodium hydroxide and water to make these two compounds? Oh, I'm working you hard today. What you got tomorrow off? We normally have tomorrow off. All right, let's get to work because it looks like everybody's done. What do we have that's different here? What's not oxygen? What's not carbon? What's not oxygen? Getting ahead of myself. Got oxygen here, oxygen with negative charge, carbons. This carbon, this is a carboxylate anion. Ooh, I got 2 carbons on this nitrogen. In this case, it's not, but it could be. Our prime and our double prime can be hydrogen. And what do you react with sodium hydroxide and water to make these two compounds? An amide. And now if we come over here, this is both of these are our prime and our double prime. And if I come back here, I'll have what's attached to the carbonyl, carbon, my R group, carbonyl, nitrogen. Now, you could write it this way. Or, and I'll make my room down here. you can write it this way. Which way is correct? Oh, so that's amides. So that's everything you want to know about amides real quick. Yes, there are other reactions, but in this semester, I only got one semester to go through everything, so I have to limit things. Now, I have a very important announcement. Important announcement. As of this point, I have covered all the general reactions that we will be covering this semester. I'll say that again. At this point, I've covered all the general reactions we'll be covering this semester. Now comes the fun part. We're going to take all this stuff out in the real world and learn about how it applies to your and my everyday life. And that's the real fun part of organic chemistry. All right, I'm going to be switching the switch. Will this be on test to the off position click? I thought I'd cover a few things that you might want to learn about. Now, when you have a benzene ring with an N2 plus, two nitrogen bond together with a plus charge, and a chloride anion, we call this a diazo group. And there's ways of putting it on a benzene ring. Now, when you have a diazo group and you react it with a phenolic compound, a benzene ring with a hydroxyl group, there can be other things on there. We have this reaction switches off, and we have, this is called a coupling reaction or a diazonium coupling reaction, and it forms a new molecule, and these are called azo compounds. This again switches off. Now, why learn about azo? Notice I say will not be on test. It must be true. It's on the slide. Did you buy that? All right, but it is true. And azo compounds are used as dyes. If you look at my shirt, if you look at your tops, if it's not pure white, I'm pure white, but that's another story. Ooh, is that awful? Anyways, these are what we use for dyes and have been since about the late 1800s. And here, because of this conjugation, if you put things like nitro groups or other things on the benzene rings, you get different colors, like blue, red, green, etc. All you gotta do is look at all the things you can dye that are not white in our life. I guess I'm not dyed. Ooh, second bad joke of the day. Now, how many of you have ever heard the term royal blue? Have you heard that? That's that real dark, almost purple blue. Where did that come from? Well, before they had azo dyes, say back in the middle centuries, Middle Ages, they would take certain chemicals from plants, it's called extracting them, and use those to dye clothes. And it was very expensive. And one of the most expensive was, this is, again, switches off. This is the indigo molecule, comes from indigo plant, and it's a very dark blue. And if you apply this to cloth, you'll dye it that dark blue, almost a purple. And it's called royal blue. Why? Because in the Middle Ages, who could afford this? The king. Nobody else had money like the king. And that's how it got the name royal blue. All right, switch is still off, but I thought I'd teach you some interesting stuff about nitrogen compounds. There's a group of molecules that contain nitrogen that are extracted, removed from plants, and they're called the alkaloids. And the alkaloids have major physiological effects on your body, especially your brain. When I was in grad school, you had to do 2 seminars, one on a topic, just a general topic, the other on a research proposal. And standing in front of the first time about 100 people, and the front row is all the organic faculty who got their knives out because they're going to ask you tough questions. It was daunting. The first time, oh, was I nervous. Then 2 years later, when I gave my second one, I was in the groove. I had no problem. And the first one dealt with Ebola alkaloids, and there are certain chemicals from the Ebola plant that certain tribes in Africa would take, and there's such stimuli that it was known that after a warrior or a hunter from one of the tribes would take the Ebola alkaloid, that hunter would stand in one place for 3 days waiting for game to come by. Boy, you really got to be buzzed not to move for 3 days. And these are amazing chemicals. Now, what I'm going to talk about are some alkaloids. In no way am I doing any kind of moral judgment on these compounds. Is it good or bad or whatever? I'm just showing you them because it's organic chemistry. And the first one is morphine. In World War II, hold on one second. Everybody see morphine on the screen? This is the best I could find on the internet. And this has a benzene ring with a hydroxyl group, another double bond alcohol, a tertiary amine, this carbon here, nitrogen with a methyl group. This is a very complex ring system. You have an ether right here, a cyclic ether, and this is something you can get from a plant. And morphine was used in World War II as a major painkiller. How does it kill pain? I have no idea, but it does. Now, if you take morphine and on these two hydroxyl groups right here, now you know what I'm talking about. One of them you make into methyl ester, you have codeine. I don't know about you, but codeine is a major, major painkiller. In fact, a couple of years ago, they stopped selling it. Even with a prescription, I think it's hard to get. Used to be at one time over the counter. Time for a codeine story from Dr. White. Do I have time? Yes, I do. Back when I was about 9, I think 8 or 9, I forgot, give or take a year. That summer, I came down with asthmatic bronchitis. Not fun at all. This is back in the 50s when they didn't have all the miracle drugs they have now to help your life be better. Well, that whole summer, I was coughing up my lungs, or trying to. I was coughing pretty bad. And I had to stay in the house the whole summer because I couldn't go out. I was sick. Well, my father, being a pharmacist who knew stuff, brought back a quart bottle of elixir terpenhydrate with codeine, probably one of the best cough medicines around. And what is that? It's 80 proof alcohol with codeine. And that, even if you don't stop coughing, you don't care. You're doing real happy good. So anyways, I eventually got well. But here's fall, and he brought back in the stores, drugstore, he had gallon bottles of stuff, and poured out. And this is back when farmers made their own stuff, not like you now, where it's prepackaged by another company. And he poured in a quart bottle the elixir terpenhydrate and brought that home for me. And every morning I have a couple of tablespoons. Well, I got well, and one morning at breakfast, he sees me take my couple of tablespoons of this stuff before I go to school. Says, you know, you're not coughing anymore and you're better. You don't need that. I said, I do. It makes me feel better. He says, yeah, I bet it does. Sure did. I was going to school with a codeine and alcohol buzz. And sure made you feel, and he took the bottle away. It was good stuff. And when I got older later, I found you could buy it over the counter, and if you signed for it, now you just need a prescription, because it's pretty strong stuff. Let's continue our discussion. Now, if you look at morphine or codeine, you take this alcohol, reacted with acetic acid. Do not try this home. It's illegal. Or if you take codeine, remove this methyl group, get back your alcohol. Each alcohol you make into an ester. We have this compound, and here's the ring system that's from morphine or codeine, and you've made esters. And this is called heroin. And that's why they now very closely monitor codeine, because some of the drug people found they could go to drugstores where the government was wise to what they're doing, and they get certain medication with codeine and convert it into heroin. And heroin, as you know, is an illegal drug that gives an illegal high. Luckily, I've never met, and hopefully I never will be, a heroin addict. Now, there are other illegal drugs I like to talk about. There's a good side and the dark side of organic chemistry, and this is the dark side. Here, if you look over here, we have a tertiary amine in this complex ring system. This is a bicyclic ring system. You have an ester here and an ester here, and this is called cocaine. Now, how does cocaine do what it does? I have no idea, but I know what the structure is. Well, I can look at it. Again, switches off. Now, here, if you look at the molecule on the screen, you have a very small an amine. I got a benzene ring, carbon here, methyl group, nitrogen, another methyl group on the nitrogen. Every bend in the carbon, and the line is a carbon, every end of the line. And this compound has a common name, methamphetamine. And it's a white solid, you can crystallize it, and we call that crystal meth. Now, if you notice, it's a small little molecule, but it's very dangerous because you can get addicted to it immediately. You don't know about it, but I'll teach you now. There's a great publication. It used to be weekly. Now I think it's monthly because of price. Anyways, American Chemical Society puts out a magazine called Chemical and Engineering News, which everybody just calls C&E News. And any articles in C&E News are 100% factual. I mean, they do an amazing job of what they put in that magazine. And I remember when crystal meth started being a social problem in the United States, C&E News did an amazing article on crystal meth. I still remember this decades later. They warned that this stuff is so addictive, use it once and only once, and you'll get addicted to it, which is why we're, at that time, and I don't know what it is now, having such a problem with addicts, because somebody would try it casually. Next thing they knew, they're immediately addicted. Now, I don't know if you've been to a rave party. I haven't, I'm old, but in the news, they would always talk about, and also TV shows like some of the cops and robbers shows, that people would take the drug ecstasy. And here's the structure. It's very similar to methamphetamine, except here you have this ether. And notice right over here, you have carbon with 2 hydrogens, 2 oxygens. This is actually an acetaldehyde. And it turns out, which I won't show you, but I know the chemistry, you can make it from sassafras oil from the sassafras tree to make ecstasy, which I guess was taken heavily at one point by a lot of people at rave clubs, because you could party hard for a couple of days and keep on going. You have a hard time, a good time, I mean. And government found out about this, and they quickly regulated the sale of this. One of the funny things that I get all the time, when they know I'm a chemist, my last name is White. Have you seen Breaking Bad? And I saw the first 2 issues, and I couldn't buy someone with a bachelor's or master's degree pulling off what he did, I could. Now, people would ask me, why don't you do that? Good question. Two reasons. One, I never want the FBI knocking at my door with machine guns and shotguns. Two, I never want competitors knocking at my door with machine guns and shotguns. But I will tell you a true story. A long time ago, I was dating this woman, and she knew people in Evanston. We were having this big party, and I went there, and the guy's home was a mansion. Turns out he and a lot of his friends were commodity brokers, which means, one, they were under a high-stress job because every day in the commodities pits in downtown Chicago, they traded millions of dollars. And if they blew it, they lost a lot of money, and a lot of it was their own every day. Well, it turned out most of them were high on cocaine half the time, which makes you wonder how they were good, but a lot of them were. And I was there, and I was introduced to people, and I already had my PhD in organic chemistry. And one of them came up to me, one of the people at the party, do you know would you know how to make this and this and this? Some illegal drug. I thought about it and said, yeah. What would it cost? And I said, well, if I want to do it right, I need about $1.5 million to set up the lab and set up production. And immediately the guy said, this was Saturday, I'll have you that Monday on Monday morning. I looked at him and said, no, you won't. Something I will not do. And later on, I asked someone else who knew this guy. I said, was he joking? And the guy said, no. If he says he can get you $1.5 million by Monday morning, he'd have you $1.5 million. So you got to watch out what parties you go to. Switch was off on there. Now, other amides, just in case you're interested, and the switch is off, you can find silk as an amide, wool is an amide. We've already talked about our hair and skin, and proteins are amides, which I'll teach you later. So next time you have a hot dog, or if you're not into hot dogs, if you have soybeans, if you're a vegetarian or vegan, you're eating proteins that have amide functions holding the amino acids together. And nylon, which I'll talk about, I'm not going to do it now when we get into polymers, is also an amide. All right, switch is on. Let's talk about heterocyclic compounds. Now, I won't ask you, but it is the largest class of all organic compounds in nature. This is what you should know. What is a heterocyclic compound? It's a compound that contains carbon atoms and other atoms in a ring, different cyclic ring. And those other atoms are oxygen or nitrogen. And I won't ask you this, but many of them are aromatic, 2n+2 pi electrons in a ring. That makes them very stable. But excuse me, you should know what is a heterocyclic compound. It's a ring that contains carbon and other atoms, and those other atoms are nitrogen and oxygen. I'll say it again. What is a heterocyclic compound? It's a ring that contains carbon atoms and other atoms. And those other atoms are oxygen and nitrogen. That's aromatic, but I won't ask that. You should know this. This is a common name, that's the IUPAC name. This is an important heterocyclic compound called pyridine. And notice it's like benzene, or if this is benzene, if you replace one of the carbons in benzene with a nitrogen, you have pyridine. Now, pyridine reacts like a tertiary amine. I won't ask that. It's heterocyclic. So if I ask on a test, what's the name of this compound, you should know it's pyridine. If I ask, draw the structure of pyridine, here it is. That's the only heterocyclic compound I asked you to learn. It's aromatic, I won't ask that. It's basic, it's a base. Unlike benzene, does not easily undergo heterocyclic compounds, but it undergoes nucleophilic substitution reaction. In other words, it reacts like a tertiary amine. Now, pyridine, if you've ever smelled pyridine, it's one of the foulest chemicals you've ever smelled. Think about putting a dead fish or two in a plastic Ziploc bag in the heat of the summer and leave it in your backyard for 2 weeks. Go back, open that bag and smell it. Pyridine smells worse. It is awful, but it's useful. If you remember, pyridine is used to make the mouthwash, active ingredient in my mouthwash, to make quaternary ammonium salts. All right, are you watching? Click. Next couple of slides, I'm turning the switch. You saw me do it, click off. Will this be on test? No, but I think it's stuff you should know about. When we talk about heterocyclic compounds, a very important one is this molecule. How many of you have heard you need folic acid to keep yourself healthy and strong, especially young children and pregnant women, which I am neither, but I still try and get my folic acid. Now, why is it called folic acid? Well, if you look up here, and these are things you know, you got 1, 2 carboxylic acids. You have an amide here, you have an amine here, and you have a heterocyclic compound there. How Mother Nature made that, I have no idea, but it is an amazing molecule. And if you think about it, it's what keeps Popeye strong, because it's an active main important component in green leafy vegetables such as spinach. You people know who Popeye is? Okay, but you know who olive oil is? Popeye's girlfriend. You know who Wimpy is? I gladly pay you Tuesday for a hamburger today. Boy, was I brainwashed. All right, let's continue on. Now, it turns out another heterocyclic, and the switch is still off, is pyrrole. Now, pyrrole is a 5-membered ring where one of the atoms is nitrogen. Now, if we look at here, we have 2 pi electrons, 2 pi electrons, and turns out the non-bonding electrons here are also in pi. So this is 6 pi electrons. Pyrrole is aromatic. Now, if you take a couple pyrrole molecules, 4 of them, and you mix them together with some more carbons, we have what's known as porphyrin. Now, switch is still off, but I think you want to see this. Porphyrins are macrocyclic compounds. Macro means huge rings. I mean, huge rings. And if you notice in porphyrin, I have 1 pyrrole, 2, 3, 4, plus I have carbons here holding it together. And if you look at all the pi electrons of this conjugated double bonds, it's aromatic. Now, it turns out porphyrins, this one, is the basis for heme, like in your blood hemoglobin, and chlorophyll, like in photosynthesis. If you don't have chlorophyll, you don't have photosynthesis. We don't have plant life on this planet, and we're dead because we don't have anything to make oxygen. And heme has iron in the center here, and has different proteins, which is called the globulin, and I'm way beyond my knowledge of medicine, that this transfers oxygen and carbon dioxide from your lungs and blood. Now, instead of iron, if it's magnesium, that's chlorophyll. And that's in the green leafy vegetables to help photosynthesis, to make them grow and do all the neat things that help save our planet. Now, switch is still off. Here we have indoles, and indoles are a class of heterocyclic compounds. Notice you got a nitrogen, this is called a fused ring, and they're key part of certain amino acids like tryptophan and found in serotonin. Interesting story. Do I have to? Oh, I do. Now, one of the things I found a number of years ago, and I always get away from it, and I'm getting back to it, is because of certain chemicals in soybeans, it helps increase the serotonin in my brain, which means I, A, think better, sharper, and B, sleep better. And if you you go to any supermarket, you can get edamame, which is the Japanese for soybean, even though all the soybeans are edamame, comes from China and the United States right now. Our soybeans are made into soybean oil and used for meal for cattle, and we sell it too, or at least they used to, the Chinese. But anyways, if you get the plain edamame, not in a pod, but just the pea part, boil it up and put it in anything or eat it with some seasoning on it, it makes me, and if I get my helping every other day or even every day, I'm doing better. Now here we have, this is called the Purine Ring. Again, switches off. I thought you'd like it. It's a heterocyclic compound, and it's found in caffeine and theobromine, which is found in cocoa. It's also found in major nitrogen bases in DNA and RNA. Now, switch is totally off, but here's the structure of caffeine. And yes, I have a mug, which somebody gave me with that structure on there. Oh, by the way, in the last couple of years, I don't know how long, it's quite popular now, tattoo artists putting serotonin molecule, people getting tattoos. I remember a couple of years ago, somebody sent me a picture and said, "You're an organic chemist. What's this?" I saw it on somebody's tattoo. I said, "Oh, that's serotonin." I said, "Why are they doing that?" And I realized that's in your brain, makes you feel good, and that's why people are putting on their body. Dr. White doesn't have any tattoos, but not there's anything wrong. In fact, 2 semesters ago, I had a student, she had on her back, and it was a spring semester, so when it got warm, she had a open top back so you could see it, and it was about this big of a chrysanthemum. Oh, it was beautiful. But anyways, this is caffeine. And how this molecule gets you buzzed so it keeps you awake, I have no idea, but it does. Now, if you notice right here, this nitrogen has a methyl group on it. If you take that off and replace it with a hydrogen, you have this compound. And here's that same nitrogen. This is called theobromide. And you know you can get addicted to caffeine. I did. I was drinking too much tea and I cut back. I still drink too much. But when I cut back, I used to drink like 8 or 9 mugs a day when I was at work. I could do easily. When I cut back, I started feeling the withdrawal symptoms. Well, theobromine is one of the key ingredients in cocoa, chocolate. How many of you, I'm not lucky, have ever had friends, neighbors, or loved ones who's a chocoholic? And those people are sensitive to this molecule and get addicted the same way we can get addicted to caffeine. And this is what makes chocolate taste good. One of the things. The other is it has whatever else in there. And by the way, Dr. White loves white chocolate better than regular chocolate. but white chocolate, quote unquote, is technically not a chocolate, but you can't convince me. Best place I've ever had white chocolate was in a candy store in Santa Fe, New Mexico. If you haven't been to Santa Fe, that whole area around there is very, 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 plus two more very wealthy people. And they have some very high-end shops in Santa Fe. This candy store was one of them. I remember crossing a stop sign in the town center. And who was waiting at the stop sign? 3 Rolls Royces and a high-end Bentley. We're talking big money there, but that white chocolate there was so good. I had a friend who used to live in Albuquerque. That's how he wound up. He took me to Santa Fe for a day, and it was quite interesting. Oh my goodness, if I look at the clock, I'm going to do something. I'm going to end early by almost a minute. Don't tell the James. And remember, Wednesday, I will be going through the carboxylic acid and ester problem set. Wednesday, hopefully our country's on the right path then. Say a prayer, we need it. Oh, by the way, as you know, I voted. And tomorrow I'm gonna go out and make sure I have a good supply of vodka in case I need it. Hopefully I won't. But anyways, with that, Wednesday, we'll do the ester problem set. Essentially, I finished up amines and amides just now, and we'll do that problem set a week from today. Week from today, I will do the review for the next test, test number 3, and a week from this Wednesday will be test number 3. By the end of the week, I'll post what it is. It'll be on carboxylic acids, esters, amines, and amides. And with that, I get to do this. Goodbye. Gang, gesund, be healthy. Say a prayer for tomorrow.